Hey guys, and welcome to Graphing Quadratics in Intercept form. So we've learned all about standard form, and now we're going to learn about a different form called intercept form. Alright, so let's look at some of our vocabulary first. X-intercepts. Well, we should all know what these are, but just in case, this is where the graph of a quadratic function crosses the x-axis, and it's also known as roots, zeros, and solutions. The vertex, which we've talked about, is where the graph changes direction. Alright, now if the parabola opens up, meaning if there's a U shape, then we have a minimum. Oops, I spelled minimum wrong. Hold on, there we go. And we can tell that from our equation because A is positive. Which means that if the parabola opens down, we're going to have a maximum. And this time, A will be negative. Alright? So far, nothing new. And our axis of symmetry is the imaginary line that passes through the vertex of our parabola and divides the parabola into two symmetrical halves, which we've talked about. So all of our vocabulary is something that we have learned before. Okay? Now, what's different is going to be our intercept form. So we have y equals a times x minus p times x minus q. So just for an example, this could be, I don't know, I'm just going to have our a equal 1, so y equals 1, and then maybe x minus 1, x minus 3. Okay? So, in intercept form, and I'll just give you the basics, these numbers, our p and our q, tell us our x-intercepts. But if you notice, in our equation, it's a negative p and a negative q. So in our equation, p and q fly. So if I have x minus 1 and x minus 3, what we're going to need to do is set them equal to 0. So we're going to take each parentheses and set them equal to 0. And we're going to solve for x. So then our intercepts are x equals 1 and x equals 3. So then we can go ahead and graph at x equals 1 and x equals 3. Okay? And then our axis of symmetry is going to be in between those 2 points. And then I'm just going to make up a vertex because we will get to that in a moment. Actually, let's go ahead and do it. Okay. So our axis of symmetry. To find our axis of symmetry, we are going to add up P plus q and divide it by 2. Alright, so our axis of symmetry is going to be 1 plus 3 divided by 2, which gives us 4 over 2, which just equals 2. Okay, and that's where I got this dashed line from. It's just directly in the middle of these 2 points. Alrighty, and then to find our vertex, well, luckily for us, that's the exact same process as it was previously. We are going to substitute in our axis of symmetry into our equation. So I have y equals 1 times 2 minus 1 times 2 minus 3. Okay, so remember your PEMDAS. Do I have things to do inside of my parentheses? Absolutely I do. So I have y equals 1, 2 minus 1 will give me 1, 2 minus 3 will give me negative 1. So 1 times 1 is 1, times negative 1, y equals negative 1. So then my vertex is 2 comma negative 1. Okay, and then we can go ahead and graph it. Ta-da! And that's our intercept form. Okay, so let's start. Let's do our first example. Alright, so we have the quadratic y equals x minus 5 times x plus 1. Alright, well, let's first solve intercepts. So we're going to take each of our parentheses, the x minus 5 and the x plus 1, and we're going to equal them to 0. And then we're going to solve for x. So I'm going to add 5 to both sides for the first one, so that x equals 5. And I'm going to subtract 1, so I get x equals negative 1. And then we can graph those. So I have x equals negative 1 and x equals positive 5. Okay. Our second step is going to be to find the axis of symmetry, which remember is going to be our p plus q divided by 2. And remember, our p and our q are what we solved for. So I'm going to have 5 plus a negative 1 divided by 2, which is going to give me 4 over 2, which will just equal 2. And remember, this is x equals. So I can graph my axis of symmetry at x equals 2. And then finally, I need to find my vertex. So I'm going to substitute this 2 everywhere there is an x in this equation. So I'm going to have y equals, I have an x minus 5, so that's going to be 2 minus 5. And then x plus 1, so that's going to be 2 plus 1. Solve inside of your parentheses, so I have y equals 2 minus 5 is going to give me negative 3. 2 plus 1 will give me positive 3. So y equals negative 9. So then my vertex is going to be 2 comma negative 9. And then we can graph it right here. And then we can connect our dots. Now if you notice, each time I have only made 3 dots, 3 points on our equation. In intercept form, that's okay. But in every other form, you need your 5 dots. Okay? Alrighty. Let's move on to our next example. Alright. So, first, solve the intercepts. So I have x plus 2 equals 0, and x plus 4 equals 0. Subtract 2 from both sides, so I get x equals negative 2. Subtract 4 from both sides, x equals negative 4. Alright. Then I'm going to solve for my axis of symmetry. Whoops, 2. So I have negative 2 plus a negative 4 divided by 2. So that's going to give me negative 6 divided by 2, which will equal negative 3. Oh, I have not been graphing things. Sorry. Okay, so we have negative 2 and negative 4, and an axis of symmetry at negative 3. Alrighty. So then to find our vertex, everywhere there's an x, we're going to put that negative 3. So now we have f of x equals, f of negative 3 equals negative 3 plus 2 times negative 3 plus 4. Okay, so then f of negative 3 equals negative 3 plus 2 will give us negative 1 times negative 3 plus 4 will give us 1. So f of negative 3 equals negative 1. And remember, this just means y. So then our vertex is negative 3, negative 1. Alright, next example. Oops. Sorry, there we go. Alrighty. First things first, solve our intercepts. X plus 5 equals 0, x minus 3 equals 0. Subtract 5 from both sides, add 3 to both sides. Okay, and we can go ahead and graph those. So I have x equals negative 5, x equals positive 3. And then for step 2, axis of symmetry. Remember, this is p plus q divided by 2, where this is my p and this is my q. Alright. So then I have negative 5 plus 3 over 2. Negative 5 plus 3 will give me negative 2 divided by 2, which equals negative 1. So then I have an axis of symmetry at negative 1. Alrighty. Final step, solve our vertex. So then everywhere there's an x, I'm going to put that negative 1. So I have k of negative 1 equals negative 1 plus 5 times negative 1 minus 3. Okay? So then I have negative 1 plus 5 will give me 4. Negative 1 minus 3 will give me negative 4. And then negative 4 times negative 4 will give me negative 16. Times the negative out in front will give me a positive 16. So then our vertex is negative 1, comma, 16. Alright. And hey, look at that. It throws in a standard form one so that we remember how to do it in standard form. Okay? So, remember in standard form, our first step is to solve our axis of symmetry, which is going to be negative b over 2 times a. Okay? So make sure you know what your a, your b, and your c are. Alright, so we have negative, parentheses, negative 2 over 2 times our a. So we have 2 over 2, which equals 1. And we can graph our axis of symmetry. And then step 2 is going to be to find our vertex. So everywhere we see an x in our equation, we're going to put that 1. So f of 1 equals 1 squared minus 2 times 1 minus 3. So we're left with 1. Negative 2 times 1 gives us negative 2 minus 3. 1 minus 2, negative 1 minus 3, negative 4. So then our vertex is 1, negative 4. Alright. And then our third step is our table of values. Move this down a little bit. Yep. So then we have our x and our y, and we make sure that our vertex is in the center, and then we go up 2 numbers and down 2 numbers. And without doing any math, our 0 is going to be our c value, which would be negative 3, which means that this one is also negative 3. So then all I have to do is use our calculator, and we'll find the rest of our table of values. So we make sure that our calculator goes on, we press the table button, I think you can see that, and then we have x squared minus 2x minus 3. Whoops, and I forgot to start up my vertex, but there it is, 1, negative 4, and then you can see 0, negative 3, and 2, negative 3. So then at negative 1 it's going to be 0, and at 3 it's going to be 0, because of symmetry. Alright, so then we can graph those. So negative 1, 0, and 3, 0. And then 0, negative 3, and 1, negative 3. Now, what do we call these values? Whoops, can't really see that. These are going to be our x-intercepts, because y equals 0. And when we graphed it, it was on our x-axis. Okay? Just bringing it all back. Alrighty. Now let's flip to the back page. Alrighty. So you guys can try number 5 on your own time, because I think you guys are pretty decent at standard form. And then, let's see. I also want you guys to do number 6. Actually, yeah, try number 6 on your own. See what you can make of that. Okay? And then I will just give you a recap of our steps. So for step 1, we are going to find our, we are going to find our x-intercepts, so we set each parentheses, equal to 0, and we solve for x. Step 2 is that we find our axis of symmetry by the equation x equals p plus q divided by 2. Step 3, whoops, I messed up my markers, but that's okay. Step 3 is that we find vertex by substituting axis of symmetry in for x's and solve for y. And then step 4, graph. Alright, and that is how you graph in Intercept form. Alright, so I want you guys to do 5 and I want you guys to do 6, and then I want you to turn it in. Good luck, guys.